enough room in your dorm for all this stuff.
Well, we'll give it a shot.
Hey, sorry about the stereo not working, but at least you got your boombox.
Yeah, got fresh batteries. We're all set.
Hey, son, remember what we talked about last night. There'll be things you'll hear in college that'll challenge your faith.
Thanks, Dad. Love you.
Love you too. Hey, keep in touch.
All right.
Don't forget to write.
Okay, Mom, I love you.
Love you too, sweetheart.
Zircon grains have been found in sandstone in Australia, and they are dated to 4.1 to 4.2 billion years. This is very important information. The facts, well, they speak for themselves, as you can see. Radioisotope dating convincingly demonstrates that the Earth is billions of years old.
Everything we believe then comes into question, if in fact the Earth is billions of years old. See, in other words, if there were billions of deaths prior to Adam in the garden and his fall, then the wages of sin is not death. It's not physical death, as Romans chapter 6, verse 23 clearly states. And if these wages of death is simply spiritual death, then why did Jesus have to die a physical death on the cross?
Class dismissed.
Dear Dad, I'm not sure where to begin or how to explain it. I remember what we talked about, but I guess I'm a little confused right now. I'm thankful for the opportunity to go to college, but it's a lot tougher than I thought. What I thought I believed in, well, Professor's pretty convincing. And now, he's not so sure anymore.
Oh, hey, Sean, how's it going?
Oh, hey, Nate. Just typing an email to my dad.
You okay?
Yeah, I guess. Not really. I'm struggling right now.
May I?
Yeah. Everything we're learning in geology class is totally against what I've learned from the Bible. What really gets to me is this constant barrage of millions and billions of years. I mean, if the Earth is really billions of years old, it sort of turns the book of Genesis on its head, doesn't it?
Well, yeah, if that was the truth.
What do you mean, if that was the truth? And how do you stay so strong in your faith?
Sean, it isn't always easy. In fact, I used to struggle with the very same issue.
You did?
Yeah. Going into geology class was like going into the lion's den. So I decided to look into it. And when I did, I found so much scientific evidence that lines up with the Bible. It's incredible.
What about all these rocks and how old they're supposed to be?
At first, I was really bothered by all the claims that rocks are billions of years old. But when I began to look into it further, I discovered some really convincing research done by creation scientists. I mean, you know, what I found really seriously challenges some of the conventional methods used for dating rocks and the age of the Earth. And in fact, I am discovering that more and more scientists are finding scientific evidence that supports a young Earth, and not an old one.
Really?
Yeah.
Well, do you have a minute to stick around? I'd like to hear more about this.
Sure, no problem.
Here.
Christians in their pursuit of truth are often confronted with conventional science interpretations which for some challenge the very core of their faith. The Bible clearly teaches that God created the world in 6 literal days. Combining the biblical chronologies with a 6-day creation suggests a young earth, not an old one. Yet mainstream scientists dogmatically assert that the earth is billions of years old. How does the Bible-believing Christian reconcile the truth of Scripture with the claims of conventional science? Should Christians reinterpret Genesis based on man's current interpretation of science, or re-examine science based on the plain teaching of Genesis? Many in the church today have given in to the pressure of secular science by attempting to unite it with the Bible. After all, how can so many scientists be wrong? What other alternative is there but to merge the views together? Is there any science that is in harmony with the straightforward teaching of Scripture? What about the claims for the ages of rocks and their fossils being millions and billions of years old? Are there minerals in rocks that can determine their age? In 1997, a group of 7 creation scientists formed a research group to explore this question and dig deeper into this highly debated issue. These scientists, known as the RATE team, which stands for Radioisotopes and the Age of the Earth, launched an 8-year research project to evaluate the reliability of measuring the age of the Earth's rocks using radioisotope dating methods. It is commonly believed that radioisotope dating provides unquestionable proof that the Earth's rocks are billions of years old. However, many people are unaware that radioisotope dating often produces conflicting results. Different methods often disagree with each other, and rocks which are known to be young, when tested, frequently yield a very old age. The RATE team has been examining this and many other challenges to conventional dating methods. The results of this study have been quite compelling. Dr. Larry Vardaman, manager of the RATE team, summarizes the story behind this 8-year research project.
Our team first met in San Diego to discuss the techniques used for dating the Earth. We reviewed the way rocks were being dated and found these methods to be questionable at best. Up until this point, supporters of a young Earth had criticized the conclusions drawn from dating rocks, but had not offered any explanation for how large quantities of decay products from radioisotopes in the rocks had been formed in such a short period of time. It was these decay products, like lead, that had been used to argue that the Earth was old. Rather than simply denying the claims that the Earth was old, our team determined to understand what processes may have formed the decay products. If we could find evidence for their source, then we might be able to explain the enormous difference between the billions of years estimated by many conventional scientists and the thousands of years concluded from a literal understanding of the Bible. To appreciate what the RATE team discovered, we must first understand the process of nuclear decay. To do this, let's look at the common illustration of an hourglass and compare nuclear decay to the sand trickling from the top to the bottom. Imagine each grain of sand representing an unstable atom called a radioisotope. During nuclear decay, these radioisotopes change into entirely different elements. For example, from uranium to lead. The rate of this nuclear decay can be measured, theoretically allowing the age of a rock to be calculated. Continuing the hourglass illustration, the sand in the top can be compared to unstable atoms, or parent isotopes. The sand at the bottom represents the decay products, or daughter isotopes. In nuclear decay, the parent isotopes, sand on the top, is always unstable and over time changes to daughter isotope, sand on the bottom. The rate of sand trickling from the top to the bottom represents the rate at which parent isotopes decay into daughter isotopes. In other words, just as a person can calculate how much time has elapsed by observing the amount of sand in the bottom of an hourglass, in theory, the amount of daughter isotopes in a rock can indicate its age. However, creationists have pointed out that this straightforward dating concept is unreliable. because it's based on three unprovable and questionable assumptions. First, it assumes that the amount of parent and daughter isotopes have not been altered by anything except radioactive decay. Second, it assumes that when the rock was formed, it contained a known amount of the daughter isotopes, in many cases believed to be zero. And third, and finally, it assumes that the decay rate has been constant throughout history. Until recently, creationists have pointed out serious flaws with the first two assumptions, citing contamination in numerous examples and unknown initial conditions. But now, recent discoveries by the RATE team are beginning to challenge the third assumption, that the rate of decay has been constant throughout time. The results from the RATE team's research strongly support the contention that the Earth is young, and nuclear processes have been accelerated in the recent past. Let's take a closer look at those results.
We begin this exciting journey by visiting Grand Canyon, which contains one of the most dramatic displays of rock layers on the surface of the Earth. The canyon's rock layers provide us with the first challenges for these conventional dating methods. What types of rocks are suitable for radioisotope dating? Let's join Dr. Steve Austin in Grand Canyon for an answer to this question.
One of the most unusual rock types in Grand Canyon is diabase. In the field, we see evidence that diabase was once a very hot liquid that was intruded between the rock layers of the upper crust of the Earth. We see these very thick horizontal rock bodies called sills in the Grand Canyon. Diabase sills ought to be ideal for radioisotope dating for three reasons. The first characteristic of diabase sills that makes them an ideal candidate for radioisotope dating is that they were injected through a crack, a nozzle, if you will, where friction and flow created mixing. Isotopic mixing is one of the requirements for radioisotope dating. A second characteristic of diabase sills that makes them an ideal candidate for radioisotope dating is that the sill is gravitationally segregated. The coarser, heavier minerals fell to the bottom and the lighter minerals floated to the top. This mineralogical separation is an ideal characteristic, especially for isochron dating. And a third characteristic of diabase sills that makes them an ideal candidate for radioisotope dating is that the diabase sill was squeezed into and between cold rock layers and allowed to cool. The cooling would occur rapidly and the crystals should read just a single age. For these reasons, diabase sills of Grand Canyon ought to be ideal candidates for radioisotope dating. I measured the abundances of different radioisotopes in the diabase sill of Grand Canyon to see if I could determine the age of crystallization of the diabase rock and its included minerals. Potassium decays to argon, rubidium decays to strontium, samarium decays to neodymium, uranium decays to lead, and thorium decays to lead. Do these different radioisotope pairs give a consistent picture of the age of crystallization of the diabase sill in Grand Canyon? Surprisingly, these radioisotope pairs do not give a consistent picture of age. What is the true age of the diabase sill in Grand Canyon? Is it A, 841 million years, the potassium-argon isochron age? Is it B, 1,060 million years, the rubidium-strontium isochron age? Is it C, 1,250 million years, the lead-lead isochron age? Or D, 1,379 million years, the samarium-neodymium isochron age? Or is it E, none of the above? the different radioisotope pairs do not give a consistent picture of age, and many of us believe that nobody has accurately dated a Grand Canyon rock.
So is this just an isolated example, or more common than generally believed? Let's have geologist Dr. Andrew Snelling, who's worked closely with Dr. Austin, answer this question for us.
This diabasil is definitely not an isolated example of conflicting radioisotope ages for Grand Canyon rocks. The lava flows of the Cardenas basalt yield a potassium-argon isochron age of 516 million years, a rubidium-strontium isochron age of 1,111 million years, and a samarium-neodymium isochron age of 1,588 million years. Also, the metamorphosed basalt flows of the Brahma amphibolites deep in the crystalline basement of Grand Canyon yield a rubidium-strontium isochron age of 1,240 million years, a samarium-neodymium isochron age of 1,655 million years, and a lead-lead isochron age of 1,883 million years.
These discordant radioisotope ages indicate to me that radioisotope decay has not always occurred at constant rate. Could it be that certain types of radioisotope decay have been accelerated more than other types of radioisotope decay? These ideas seem to be consistent with the data that we have obtained from the diabase in Grand Canyon.
Conventional science teaches that the dates obtained through these dating methods are indisputable. Yet, we know they disagree with each other. We literally found a billion years difference in the reported age of a rock, depending on which of the conventional dating methods were applied. This disagreement begs for an explanation. Could this disparity exist because the rate of decay is not as constant as is commonly believed? Could Grand Canyon rocks offer clues that radioisotopes have not decayed consistently throughout Earth history? What other evidence would we expect to see if decay rates were faster in the past? Let's examine helium, a byproduct of uranium decay. Dr. Russ Humphreys is a physicist and researcher who has studied helium gas that is trapped within rock-forming minerals. Do concentrations of helium in rocks indicate a consistent or inconsistent rate of decay in the past?
Well, I want to show people an ordinary piece of granitic rock. This is called granodiorite, and you'll notice when you look closely at the rock that there are flecks of black mica in it. Now, usually in each of those pieces of mica there are microscopic crystals of zirconium silicate. We usually call them zircon or zircons. These zircons are radioactive, and they're radioactive because as they form in molten rock, as the molten rock cools, the zircons form crystals, and as they form crystals, they grab uranium atoms from the molten rock around them. Uranium atoms are not completely stable. Every now and then, they spit out an alpha particle. An alpha particle is 2 neutrons and 2 protons. The protons are the red particles. The neutrons are the blue particles. Imagine that I'm very tiny, about the size of a microscopic zircon crystal, and I'm having one here in my hands. So now imagine the uranium atoms sitting in that crystal. So a uranium atom will spit out an alpha particle. That alpha particle will go out in the crystal a little ways and stop, and then it grabs 2 electrons and it becomes a full-fledged helium atom. Helium is a lightweight, fast-moving, slippery, chemically slippery atom. By that I mean it doesn't like to stick to any other atoms. It's a snooty atom, which is why they call it a noble gas. But that means that it just doesn't stick to other atoms, and it can wiggle through the crystal structure of atoms. It can just wriggle right between the atoms and out of the crystal. And it's used in laboratories to detect leaks, very tiny leaks, because helium is such a good escaper. So helium leaks out of these zircons. And the smaller the zircon, the faster the leaking can take place. And the hotter the zircon, the faster the atom bounces around and the faster it leaks. The rate with which that happens is very important because it tells us, gives us a way to estimate the age of the crystal from the helium leakage. So you just take the amount of helium that has leaked out of the crystal and divide by the leak rate, and you get the helium leak age. And that's very young, 6,000 years. So you can tell from the amount of lead in the crystal, and dividing by the nuclear decay rate, you can tell how long it would take at today's rate to get that much lead. And the answer you get for the crystals we looked at is about 1.5 billion years. These two hourglasses represent two different ways to measure the age of a zircon. The hourglass on the left represents uranium to lead dating, with the purple sand grains representing the uranium atoms. The hourglass on the right represents helium leak dating. The valve on the nuclear decay hourglass represents God's way to control the rate of nuclear decay. Now the valve opens all the way, and the uranium atoms begin to decay very rapidly, or by accelerated nuclear decay. As they decay, uranium atoms turn into lead atoms, represented here by the gray sand grains, which fall to the bottom half of the hourglass. At the same time as uranium decays, it produces helium atoms, represented here by the yellow sand, moving from the left to the right hourglass and beginning to fill the top. In a very short time, much of the uranium has decayed to lead. The valve closes almost all the way. Accelerated decay has slowed to the normal rate we see today. Notice the large reading on the uranium hourglass. Almost 1.5 billion years worth of decay has taken place in a very short time. Notice the small reading on the helium hourglass. Very little helium has leaked out of the zircon to the bottom half. Now we watch the helium leak for thousands of years. Notice that very little uranium is decaying to lead now. After 6,000 years, notice the helium reading. About half the helium has leaked out of the zircon. On the other hand, the uranium reading has advanced 6,000 years to become exactly 1.5 billion years. Which reading is correct? The helium hourglass, because its rate did not change. So we think we have very strong evidence that 1.5 billion years worth of nuclear decay occurred within 6,000 years ago.
Can it really be true that more than 1 billion years of decay took place over thousands of years? Now, by observing the excess helium in zircon crystals produced by the massive amounts of nuclear decay, we have evidence for a time when there was accelerated decay in Earth's past. Because of how easily and steadily helium leaks out of zircon crystals, there should be virtually no helium after billions of years. It would have leaked out before now. And because of the amount of helium we find today and how quickly helium leaks, it appears that massive amounts of nuclear decay happened only about 6,000 years ago. This evidence shows that nuclear decay did not happen steadily over 1.5 billion years, but rather 1.5 billion years worth of nuclear decay happened in a very short period of time, only a few thousand years ago. So helium diffusion, which is a compelling dating method, brings us to the conclusion that the age of these rocks and the Earth is only about 6,000 years, not billions. If it is true that decay rates were once much faster, it stands to reason that there should be other telltale signs. Well, let's go back to the rock record and consider two kinds of physical scars in mineral crystals: radiohalos and fission tracks. Let's first take a look at radiohalos. What are radiohalos, and what do they tell us about the past? Geologist Dr. Andrew Snelling has considerable expertise in this subject and has collected data on the distribution of these physical scars in the rock record. The scars tell a fascinating story.
Within granites, a number of different minerals, and one of the major minerals is a mineral called biotite. It's a black mica. It's a flaky mineral. And when it grows in a granite, as the granite crystallizes, it sometimes includes within it tiny little grains of another mineral called zircon. That mineral incorporates within it trace amounts of uranium, so that zircon grains are radioactive. And the radioactivity shoots out, we call it alpha particles. These are little radioactive bullets, leaves holes, as it were, in the crystal lattice. And so when you look down a microscope, you see this zone of discoloration where the crystal is being damaged. So when uranium decays by radioactivity, there's actually 8 steps where bullets can be formed, and they're all different. If you find a fully developed what we call a uranium halo, you actually find 8 rings. The significance is that a radio halo to be formed requires the equivalent of 100 million years worth of radioactive decay at the rate that we now measure it. And the fact that we can find them at the bottom of the Grand Canyon, right to the top of the Grand Canyon, and rocks younger than the top of the Grand Canyon, right from the pre-flood right through the flood record, means that the radio halos provide evidence that throughout Earth history there was hundreds of millions of years of radioactive decay. In the biotypes within the granites, not only do we find these uranium halos around the zircon crystals, we also find these polonium halos that are formed just from polonium. Okay. Now, to explain how the radio halos form, the polonium radio halos form, the first thing is to understand is that instead of looking down on top of the biotite flake, we're looking sideways. Often we find a uranium halo and a polonium halo side by side in the same biotite flake. Where did the polonium come from? And the source of the polonium will be the zircon crystal that is at the centre of a uranium halo. Inside the zircon crystal you've got uranium that's decaying down to radium and down to radon and then finally to polonium. As water, hot water at the end of the cooling phase of a granite travels through the minerals in the granite, it picks up polonium from the zircon and it actually forms a halo right there from the polonium. The only way that you could produce these radio halos from short-lived polonium isotopes is that the process had to occur extremely rapidly, which meant the granite had to form extremely rapidly. Here we have physical evidence also that that radioactive decay was accelerated, because here we have side by side in the same biotite grain, say a polonium radio halo and a uranium radio halo, and I've got lots of examples of that. And so here we have physical evidence that uranium decay, 100 million years worth of uranium decay, occurred in a matter of days.
So this research suggests 2 things. First, uranium radio halos are physical evidence that a lot of radioisotope decay has occurred in the past. Second, the existence of radio halos from both polonium and uranium in close proximity to each other confirms that uranium decay was accelerated and that it happened in a very short period of time, far less than the claims of billions of years. Now let's take a look at the second physical scar. Just like radio halos, fission track seems to show that radioactivity was dramatically increased in the past. Exactly what is a fission track?
When a uranium atom splits, it divides into 2 almost equal sized particles that fly apart in opposite directions. It's like 2 bullets going in an opposite direction. Together they form a straight line, and as those bullets go out, fly apart, as you can see, they leave a trail of damage like a bullet going through a plaster wall. So they damage the crystal on either side of the original uranium atom, and the sum total of that damage is the fission track. We selected 3 volcanic ash beds that we knew would contain zircon grains. We selected 2 volcanic ash beds at the bottom of the Grand Canyon, in conventional terms 500 odd million years ago. We selected then volcanic ash beds in the Morrison Formation, and then finally at the very top of the Colorado Plateau in the Kingman, Arizona area, we have what is called the Peach Springs tuff. We have found that definitely in the Morrison Formation volcanic ash beds and the Peach Springs tuff bed at the top of the sequence, very recent. Each of those volcanic ash beds had fission tracks, a quantity of fission tracks equivalent to their radioisotope ages. We were expecting to find that there would be 500 million years worth of fission tracks, and therefore 500 million years worth of nuclear decay. Originally there were lots of tracks, fission tracks, 500 million years worth, but at the end of the flood, because of the heat of the pushing up the plateau, it healed all those fission tracks and the process started over again. But we can certainly say that the fission track evidence in the geological record does confirm, first of all, that there has been hundreds of millions of years worth of nuclear decay through Earth history, and therefore we have to conclude, if we're looking at Earth history from a biblical timescale of only thousands of years, that huge amount of nuclear decay had to have occurred very rapidly.
Rate research has revealed 3 indicators that suggest that radioisotope decay was accelerated in the past. First, the dramatic disagreement between uranium-lead dating and helium diffusion. Second, the rapid formation of uranium and polonium radiohalos. And finally, the amounts of nuclear decay products that match the number of fission tracks. Individually, these indicators are significant, and collectively, they present an even more impressive case that there is something decidedly inconsistent about the behavior of radioisotopes in the past. Present-day decay rates seem so stable that they are widely regarded as absolutes. But is there any reason why faster decay could not have happened in the past? Let's ask physicist Dr. Eugene Chaffin.
In our studies of alpha decay, it is found that small changes in the strength of the nuclear force can lead to large changes in the half-life of a nucleus, such as uranium-238. The nuclear force can only act over a finite distance called its range. In a commonly used nuclear model, the alpha particle is confined to a potential well whose depth measures the strength of the nuclear force and whose boundary allows the nuclear force to slowly decrease as the particle gets outside the range of the nuclear forces. Using realistic values for the strength and range for the nuclear force, it was found that a small change in the depth of the nuclear potential can cause a change in the number of nodes in the alpha particle wave function, resulting in a change in the half-life that in some cases could be as much as a factor of 100 million. It was found that these models are consistent with the uranium isotope distributions found in nature and their approach to radioactive equilibrium. These results enable one to conjecture about how much the variation in nuclear force must have been in order to explain present-day isotopic abundances.
So there appear to be factors that, if adjusted, could produce accelerated levels of decay in the nuclei of atoms. Up to this point, we've examined long-age radioisotopes. But what about short-lived radioisotopes? What about dates obtained from the decay of carbon-14, frequently referred to as carbon dating? It is common knowledge that radiocarbon dating is used to date bones and artifacts. However, most people are unaware that carbon dating is rarely used to date rocks thought to be very old. But what does it mean when we find carbon-14 in what is believed to be an ancient coal bed, or even a diamond? Here's geophysicist Dr. John Baumgartner.
Well, in today's world, carbon-14 is produced all the time in the atmosphere as a result of cosmic rays that come blasting in from outer space. And most of these cosmic rays consist of a proton, a very high energy proton, traveling at near the speed of light, and comes it blasting into the atmosphere, collides with an atom of oxygen or nitrogen in the atmosphere. There's almost like an explosion when this high energy particle encounters one of these atoms. It produces all kinds of other particles, including neutrons. And these neutrons, in turn, can interact with nitrogen atoms in the atmosphere and produce carbon-14. So we have carbon-14 being produced all the time in the atmosphere by this process. And it's only about one atom in a trillion carbon atoms in the atmosphere that is a carbon-14. So the amount of carbon-14 is very tiny. only about 1 atom in a trillion.
Plants take in carbon dioxide and through photosynthesis produce new plant tissues. While a plant is living, its tissues have the same ratio of C14 as the atmosphere. Animals, in turn, eat plants, and they also have C14 throughout their tissues with this same ratio. However, when plants and animals die, there's no longer this active connection with the atmosphere. In the remains of the dead plant or animal, the ratio of C14 to other forms of carbon steadily decreases over time due to radioactive decay. The longer the plant or animal has been dead, the smaller the ratio. This is the basis for C14 dating.
Carbon-14 in coal, it simply is the carbon-14 that was in the trees and other kinds of plants that were buried in the flood. So the way that this carbon-14 got into the coal was simply, it was in the living organisms before the catastrophe. The catastrophe ripped up the trees and plant life and buried them in thick layers that got compressed and formed into coal. So it's relatively simple to understand how the carbon-14 got into the coal. The big issue is why hasn't it, if the Earth is millions, hundreds of millions of years old, if it's been hundreds of millions of years since that happened, why should there be any carbon-14 still left? There's no technique on Earth that can measure levels of C14 in materials that are older than 100,000 years. So the fact that we find so much C14 in coal and other kinds of fossil organisms indicates that their age is much less than 100,000 years. Secular geologists have documented that very well. We had 10 coal samples analyzed, all collected in a similar manner by the U.S. Department of Energy, all analyzed by what we deem the best radiocarbon laboratory in the world. And one surprising result was that within the statistics of our samples, that there was no difference in the levels of carbon-14 in the coal near the top and the coal near the bottom, which indicates that all of this material lived at the same time and died at the same time. Strong evidence that the entire fossil record has the same age. In addition, we analyzed several diamonds for carbon-14, hoping we would find C14, but unsure about it. And so it was extremely exciting to get the first results back and to find significant levels of C14 in diamond, something like 100 times the detection threshold. And this is very significant because diamonds are formed deep in the earth, on the order of 100 miles down in the earth, generally believed to have formed early in the history of the planet. And because diamonds are the hardest substance in existence, it's essentially impossible to contaminate a diamond. So what this means is that the earth itself must be young, only a few thousand years old, else the carbon-14 in these diamonds would long since have decayed. And so this carbon-14 must date, we believe, to the original creation of the earth itself, just a few thousand years ago. The levels of C14 we're finding indicates that all these fossils lived at the same time, were buried at the same time, just a few thousand years ago. And this is an extremely significant result and strong support for the biblical account of a global flood just a few thousand years ago.
Why is there any measurable radiocarbon in rocks which are supposed to be billions of years old? What's more, why is the same level of carbon-14 found in deep earth diamonds, as well as fossils from top to bottom of the fossil record, if the earth was formed billions of years before animals and organisms appeared on the scene? Is this clear evidence supporting the argument that the earth is thousands, not billions of years old? We've looked at the scientific evidences for a young Earth. What about the biblical account of creation? A casual reading of Genesis suggests that the Earth is only thousands, not billions of years old. But let's dig a little deeper and hear from Hebrew scholar Dr. Stephen Boyd regarding his extensive word study of Genesis and other Old Testament passages.
Really, the question is, how should we read Genesis 1:1 through 2:3? And I think a more fundamental issue is not how can we read it, but how should we read it? Because it can be read in three different ways. It can be read either as some kind of a myth, which teaches truth, which essentially is the old Earth view. The old Earth view is that this is a myth that teaches truth, and they read it as poetry, okay? The second way is to say it is narrative, and the author believed what he was saying. He believed that God created Earth in 6 days. He really believed that, but he was wrong. That's the liberal perspective. The third way is to say it's a narrative. He believed he was narrating truth, and that's exactly what it was. That the text corresponds to what is with reality. So that's really the three ways. Because what I've done is a statistically rigorous study of the text, looking at poetic text versus narrative text, identifying poetic and narrative text throughout the Hebrew Old Testament, and then statistically determining that those types of texts are different based upon certain specific features regarding the types of verbs that occur. And it turns out that the verb distribution, that is the types of verbs, what's called a preterite, that type of verb is distinctive for Hebrew narrative and marks Hebrew narratives. Now, this has been known a long time, but not actually established statistically. So it shows that Hebrew narrative and Hebrew prose are distinguished by that particular ratio of the preterite to the rest of the finite verbs. The finite verbs are the preterites, the perfects, verb perfects, and imperfects. And so when we take the number of preterites over the total number of finite verbs, we find out that ratio is much higher, usually about 40% for narrative versus for poetic text. Now, having established that and to a high level of statistical significance, the second thing is that can you use that then to predict if you have a certain distribution of finite verbs in a given text, can you use that to predict what type of text it is? And again, using statistics, inferential statistics, using logistic regression, we can, to a high level, about 6 figures in terms of statistical validity, we can determine that Genesis 1:1 to 2:3 is a narrative to a 99.9973% accuracy. So this is extremely important in terms of foundationally to show that Genesis 1:1 through 2:3 is narrative, not poetry. You get a young Earth if you read the text in a straightforward way and understanding it to be a narrative.
Again, the Bible clearly teaches that God created the world in 6 literal days. But some may wonder, what is so important about the debate over the age of the earth? Well, it all boils down to the defense of Scripture. If we don't stand firm and earnestly contend for the faith, then the authority of Scripture is jeopardized, and sound doctrine will begin to slip away. So at the heart of this research is the defense of the plain teaching of the Bible. If we cannot take Genesis at face value, the rest of Scripture comes into question. The evidence for a young earth is quite convincing and should at least cause those who believe that the earth is billions of years old to re-examine the evidence. The supposed old age of rocks and fossils is really the linchpin of evolution. The rate research has not only questioned these dating techniques, but it has offered real evidence that the earth is thousands, not billions of years old. Let's summarize the main scientific and theological conclusions drawn from this research and let you be the judge. We know that a large amount of radioisotope decay has occurred. Conventional dating methods are highly inaccurate and inconsistent. Nuclear decay appears to have been accelerated at different periods during Earth's history. There should be virtually no helium or carbon-14 in rocks, diamonds, or coal if they're actually millions or billions of years old. The fact that there is indicates that the Earth is only thousands, not billions of years old. And finally, the narrative language in the creation account strengthens our confidence in a literal understanding of Genesis 1. In other words, Scripture means exactly what it says. While there is more research to be done, the rate study certainly calls into question the claim that the Earth is billions of years old. So today, more than ever, Christians can stand strong in their faith by taking the time to examine the increasing scientific evidences that support the book of Genesis. As Christians learn how these scientific discoveries bring serious challenges to conventional thinking, they can come to understand that true science and the Bible really do have the same author.
Wow. I had no idea there was that kind of research being done.
Yeah. Well, hey, listen, I gotta go. If you hang in there, we'll hook up later.
Dad, I'm really looking forward to my trip home next week. I've got some great news to share with you and Mom.